So tell me a little bit about where are we with brain computer interface? First of all, let's define it. What is a brain computer interface? When do you say it's working?
Yeah, so it is one of the more exotic and glamorous looking thinking, because once you think about brain, it's always amazing and mystical. And we always think computers cannot do what human brain does. So how do you connect to that brain, learn from it, do something? But it all actually started with a health disorder called ALS, amyotrophic lateral sclerosis. It's a terrible disease where your brain is intact, but your nerves, and it's what's called myelination and insulation, breaks down, and the person progressively loses all body functions. So the only way you can connect to that person is through their mind, through the brain. And so that was an incentive to say, can we study the brain waves, what I call electroencephalogram, to open up the window into the mind, into the brain. But once that took off, there was other ideas. Oh, how about a paralyzed individual? Can they use the brain wave to capture the signal and control a prosthetic arm? And once you start opening up, new opportunities come about. And now, as magical it seems, I'll do something that's very magical, right? So I'm holding a phone and I stare in it and I touch a couple of buttons and I can talk to my wife in US. And imagine 10 or 20 years ago, somebody would say like, what? How can face and video and audio go across the world and we can communicate? So that's magical, but we take for granted. So now put the phone down. And why is it so impossible to think that brain waves, decode the brainwave message? So you need to know good mathematics, good engineering, good computer science. And then from there, you interpret the brainwave and decode into a message and send it to a computer or a robot or a prosthetic arm. So it is magical because to studying brain is not easy, but it is doable. And that's where we are.